So this is the last video for exponential or logarithmic and functions, which is inversely related to exponential functions. And we're going to talk about one more base before we even get into translation. So the last base we talked about was f of x equals log base 2 of x. And then we talked about f of x equals log base 10 of x. Well, on this one, we're going to talk about f of x equals log base e of x. We don't write it like that anymore. We stopped writing like that in 1905, but we rewrite it as the natural log of x. So basically, what we're dealing with is the base e, right? So same rules apply. Vertical asymptote at, yeah, I know, x equals 0. Domain of f of x is the same thing, 0 non-inclusive, and it goes to infinity. The range, once again, of f of x is equal to all real numbers. Now, the most fascinating thing about this e is that it still applies the same way as before. -1, 0, and then we're going to deal with, next is 1, and then we'll deal with e, and then we'll deal with e squared. Okay? Well, obviously, natural log of -1 does not exist. Okay, and some teachers will even do this. They'll put D and E. And no, it's not some Dungeon and Dragon an acronym. It means it does not exist because you get an error. Same thing for 0. You have that vertical asymptote. It's an error. Now, the natural log of 1, and I'm asking, is anything, any logarithmic form when x is 1, you get, yeah, 0. The natural log of e is the same thing as log base e of e. Well, what power of e gives you e? Obviously 1. And then the natural log of e squared is equal to, well, log base e of e squared will give you, as fancy as it is, it gives you, what power of e will give you e squared. So obviously, if you want to take e and you want to square it, you're going to get 2. Okay? And so it is kind of fascinating. So let's go ahead and talk about graphing it. So if you graph it, draw your graph. Another note, if I did e cubed and I did the natural log of e cubed, it's going to get 3. We can graph those two. I mean, it doesn't matter to me. Draw your vertical asymptote. I'm going to do it with the red line. You cannot cross this line. Okay, so x equals 0. I'm going to draw a point at 1, and I'm going to do when x equals e, which is 2.7, so that's 2. So we're going to do e right here. I'm going to do e squared over here, and I'm going to do e cubed. Okay, extend my line out. Make sure you label your axes. Okay, and I'm going to use blue points to represent it. Well, at 1, I'm going to be at 0. At e, I'm going to be at 1. So e 1. So that point is e and 1. When I'm at 2, I'm right here. So I will be at e squared, and I get 2. At 3, be the same way. It's going to give me another point, e cubed, I get 3. So as you can see right here, I'm going to approach the vertical asymptote as I come off and decrease from infinity, and you get this function. And this function is f of x equals the natural log of x. where everything's s and base e squared, e cubed, e. So remember that e is a irrational number, so e is an element of the set of not rational numbers, and e is approximately equal to 2.718 extended forever and ever to 8. Okay, it is an irrational number. It goes on forever and ever. Okay, well, this is basically the function of x equals natural log of x. The next lesson, I will give you the translation algorithm to move it left and right, up and down. Okay, so there are other types of translations, obviously, where you have reflections, vertical, horizontal stretches, y stretches, x stretches, x reflections, y reflections. So, I mean, it all depends on what you want to do, but the basic thing, I want you to learn how to move it left and right, up and down. If you can do that, that's fine. You can expand upon that later. But that's basically the stuff you really need to know. Once again, you'll need to tell me the range, the domain, the vertical asymptote, give me a table of values, and graph. So, hope these videos have been helpful. If you have any issues, let me know.